Good morning, good afternoon, or good evening. This is going to be a one-off question work through for the question on screen now. This is a very unusual type of vector question and has a very challenging, quite a deep method associated with it. So here we have a triangle, we have a point Q, and we have a point P. We've been told various things to get from O to A, O to B, and from A to P, and we need to try and find the vector, the ratio, from A to Q. The difficulty is we don't know where Q is. All we know is that Q is on the line OP and Q is on the line AB, but we don't know how far along. And in particular, the answer to the question, that ratio, is asking how far along AB is Q. So the only thing that we can do is to try and set up some ways to get to Q. And that's going to be our aim. So our aim is to find O to Q in two ways. And if we can find how to get from O to Q in two different ways, well, those two different ways have to be the same, and then we're actually solving some simultaneous equations. So to start with, we can notice that Q is on OP. We don't know how far along, but Q is on OP. So let's try and find the vector OP. So OP is, well, O to A plus A to P. We've been given both of those already. So let's add the 4A and the 2A plus 8B. So that's 6A plus 8B. And this is where the magic comes in. O to Q, therefore, is some fraction of O to P. So O to Q, I'm going to say, is lambda O to P. I'm using lambda more out of habit. This is we use these Greek letters more when we do vectors at higher levels, at A level maths and further maths. So that is saying if I do lambda times the OP that I already have, that's 6 lambda A plus 8 lambda B. So I'm halfway through my aim, but that was the easy one. I've worked out one way to get from O to Q by using the fact that Q was on OP. I'm now going to do the same thing, but now I'm going to use the fact that Q is on AB. Well, again, I need a couple of things. I need AB first. Well, if I want to go from A to B, I need to go backwards along A, forwards along B. So that's negative 4A plus 6B. And now I'm going to try and write OQ again. This time, OQ can be O to A, and I want to go in the direction of A to B, but again, I don't know how far along A to B I need to go. I need to go some fraction of the way across. So I'm going to add on some multiple, and I'm going to use another Greek letter. I'm going to use mu, the Greek letter that kind of looks like a U and or an M if you're looking at the tail. So O to Q is from O to A, and then some multiple of A to B. So let's put that in and try and simplify it. It's going to be 4A plus some multiple of what I've just worked out. Now I'm going to expand out that bracket and collect some like terms. So I've got 4A minus 4 mu A plus 6 mu B, and then I'm going to factorise on the A's. The reason for doing that is I can now compare the OQ that I have up here with the OQ that I've just worked out here. Now these are two different ways of getting from O to Q, but they have to be the same way. So what that means is this 6 lambda has to match whatever this 4 minus 4 mu is. And this 8 lambda has to match this 6 plus mu. The things in front of the A's match and the things in front of the B's match. So that means that 6 lambda is equal to 4 minus 4 mu and 8 lambda equals 6 mu. Well, now we can see that point I made a second ago, that these are simultaneous equations. We have two equations in two unknowns. Let's try and solve them. My first instinct here is to try and cancel common factors. I can see a lot of factors which are easily cancelable. So I'm going to divide the top equation by 2 and the bottom equation by 2 to simplify both of those. Well, maybe that was useful, maybe it wasn't, because now our method of simultaneous equations is to try and make the coefficients match up. Let's try and make the mu's match up, because one's positive, one's negative. So I'm going to times the second one by 3. And actually I've realised now that I've done more work than I need to. Times in that second one by 3, we get 9 lambda equals 6 minus 6 mu. And I'm going to have to times the second one by 2, so undoing the simplification that I did. And now we've got positive mu and a negative mu with the same coefficient. So if I add these two equations, I get 17 lambda equals 6, so lambda equals 6 over 17. And we also know then from that equation that 8 times this equals 6 mu, which works out that mu is 8 over 17. Not particularly nice. I'm not really happy that they look right, so I'm going to check in the other equation. I'm going to sub back into this one just to see if it works. 6 times 6 over 17 for the 6 lambda is 36 over 17, and 4 minus 4 lots of 8 over 17, and I'm a little worried that this is, oh, it is 36 over 17 as well. A little worried that I might get a negative there, but both sides match up. These are the correct mu and lambda. So what does that mean? That means if we look back to where we had introduced our lambda and our mu, well, those are the fractions of those lines. So this is telling us from the lambda that O to Q is 6/17 of the way from O to P. From this one here, we're now getting that O to Q is 6/17 O to P. Well, that tells us the fraction along there, but that's not the one I cared about. I cared about the AQ and the QB. So if we look to where we introduced mu, this is saying that A to Q, I'm going to ignore the O to A bit, I just want the A to Q, is 8/17 of A to B. Well, that gives us our ratio. The A to Q part is 8 parts, and the left over, the Q to B, is 9 parts. That makes the fraction 8 out of 17 and gives us the ratio that we cared about. Very unpleasant question. It is about setting up two ways to find O to Q and then solving simultaneously. As always, please do send any questions my way, and hopefully that did help with that question.